You are welcome to Math Demystified. Right at the beginning of this lesson, I would like to take us through some expressions that will be necessary and that will be used or required in this lesson. I will just give the meaning and give you examples to back them up. Now let's start with even numbers. Even numbers are numbers that can be divisible by 2, meaning when 2 divides the number, you will not have any remainder. For example, when you have 2, 4, 6, like that, and so on. These are even numbers. Some people think even numbers are only positive numbers. That is not true, because if I pick -2 and pick -4, -6, -8, and so on, you see that 2 can divide each of these numbers without a remainder. So all of these are even numbers. So we have positive even numbers, we have negative even numbers. Some people think that 0 is neither odd nor even. It's not true. 0 is also an even number, because if you pick 0 and you divide 0 by any even number, you will have 0. 0 over any number will give you 0. So 0 is an even number. Now we have learned that we have negative even number, 0 is an even number, and we also have positive even number. As long as when you divide by 2, you don't have a remainder, we regard the number as an even number. Let's look at the next one. Odd number is the opposite of this. When you divide a number by 2 and it gives you a fraction, and you cannot cut to have whole numbers only, the number is odd. And we also have negative odd numbers and positive odd numbers, like 1, 3, 5, and so on. You can also have -1, -3, -5, and so on as your odd numbers. I'll clean that part so that we can have more space here to write examples on the other. Factors. Another word for factors is divisor. That is something that can divide another thing without a remainder is called a factor. Any number that can divide any other number without a remainder is called a factor. So we see that a number can divide itself. So a number is a factor of itself. 1 can divide every number. 1 is a factor of every number. I hope you got that now. So if I write any number, say I write 5 right now, 5 can divide itself. So 5 is a factor of 5. And 1 can divide the 5. So 1 is a factor of 5. So for any number you have, the number itself is a factor of itself, and 1 is also a factor of the number. Then you can now think of any other thing that can divide the number without a remainder. So let's take an example now. Say we have 9. 9 is a factor of 9. Then 3 is a factor of 9. And 1 is a factor of 9. Don't ever forget that 1 is always included in the factor, and the number itself is also included in the factor. Prime numbers. The word prime number. Prime numbers are numbers that have only 2 factors. Prime numbers are numbers that have only 2 factors, meaning that there are only 2 things that can divide them. Only 2 factors, only 2 numbers can divide them without a remainder. And the very first prime number is 2. 2. No, 2 can divide 2 without a remainder. Okay? And 1 can divide it. That's all. So 2 is the first prime number. Let's pick another one. 3 can divide 3. And 1 can divide 3. There's nothing else that can divide. Nothing else can divide this. So you can see 2 has only 2 factors. 3 has only 2 factors. If I pick 4 now, 4 can divide 4. 2 can divide 4. 1 can divide 4. that makes 4 not to be a prime number. If I pick 5, it's only 5 and 1 that can divide 5. So when a number can only divide itself and 1 can divide it, you say the number is a prime number. If what can divide the number is more than 2 factors, then it is not a prime number. No, who can answer me what a prime factor will be when you pick prime and you combine it with factor? From the word factor, what can divide? Okay, from the word prime, there are only 2 of them. So when they give you a particular number and they ask you to fish out all the prime factors, for example, if I have 10 right now, I know that 10 has its own factors. The factors of 10 is there, 5 is there, and 1 is there. 5, in fact, more than that, you have 1 is a factor, 2 is a factor, 5 is a factor, 10 is a factor. Amongst all of this, which of them is prime? A prime number. This is a prime number. This is also a prime. No, this is a prime number. Yes. This is also a prime number. So these are all the prime factors of 10. Meaning that prime factors are factors of a particular number that are prime numbers. Prime factors are factors of a particular number that are prime numbers. Okay, let's take another one. Say we have 15. What are those things that can divide 15? 1 can divide 15 without a remainder. 3 can divide 15 without a remainder. 5 can divide 15 without a remainder. And 15 can divide itself without a remainder. Among all these numbers, which of these numbers are prime numbers? This is prime number. This is also prime number. This is also a prime number. So these are now called prime factors of 15. So let's go to integers. I need to clean the board so I can have more space. Integers. Integers are, what would I call it now? Say integers are countable numbers, countable whole numbers. When I say countable whole numbers, I mean positive and negative. One of the ways I explain integer to students is I just tell them to remember their number line. You know, on your number line, you have 0 at the center, you have 1, you have 2, and so on. You have -1, you have -2, and so on, like that. It goes to the left, and this goes to the right. This is how your integer looks like. So you start from negative, uncountable, to 0, then continues to positive, uncountable, like that. So this is how your integers look like. So when you're asked to write integers, you can just say that dot, 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 maybe -3, -2, -1, 0, 1, 2, 3, dot, 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 like that. It must contain negative whole numbers, must contain 0, and contain other ones. That is integer. Positive integers. All these numbers, those ones that are positive. Of course, this is negative, it's not positive. This is neutral. It's neither positive nor negative. And this is positive. So positive whole numbers starts from 1 as positive integers. 1, 2, 3, 4, and so on. Okay? And this 3 dots is very important in this topic. There's no way I can exhaust the list in this set. Of course, you know that. And negative integers, from what we have over there, dot, 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 maybe -5, -4, -3, -2, and I'll stop when I get to -1. So all those are my negative. Now, natural numbers, you see, when you want to count things naturally, you start from 1, 2, 3, and so on. We don't always start with negative. If I put some items on the floor now, I say, count these things. You won't say 0, you won't say -2. You start by saying 1, 2. So the way we count naturally. And that will make us know that natural numbers and positive integers are the same set of numbers. So natural numbers, 1, 2, 3, 4, blah, blah, blah. Positive integers, 1, 2, 3, 4, blah, blah, blah. So they are the same thing. Thank you for listening. we shall take this example to explain some of the things we just learned. List the elements of the set. A. Even numbers less than 50. B. Natural counting numbers. Now, in this topic, even though we know that even numbers can be negative, 0, and positive, in this topic, we only deal with the positive aspect alone when it comes to even numbers. So, even numbers that are less than 50. So, you know that the first even number will be 2, followed by 4, 6, 8, 10. If I continue to take time, so you may just put dot, dot, dot. They said less than 50. So the next number will now be what? 48. And that will be it. Less than 50. You have to be careful when you're writing that. Now, B, natural counting numbers. Those natural numbers. And you see when you're counting numbers naturally to start from 1, 2, 3, 4. And the list is much. So this you cannot exhaust. So you just stop like that. And that's it. Now, the next thing is to explain the number of elements in a set. This number of elements in a set is also called the cardinality of a set. The cardinality of a set, and this is how we represent it. If I write ordinary A like this, it means list all the members of A. List all the members of A. But when I do this, I'm saying just write the number of elements in A. I hope that is clear. Write the number of elements in A. For example, if all the elements in A are, let's say 1, 3, 7, and 5 and 9, for example. If this is my set and I put this, I'm saying count 1, 2, 3, 4, and the answer will be 4 without any curly brackets, just like this. So number of elements in a set, which is called the cardinality of the set. So N bracket A is short for the number of elements in set A, and that's what I just explained right now. So let's take this example. Example 2. If W equals whole numbers between 2 and 10, be careful for this word, between. So that means that 2 and 10 are not inclusive, and they said they are whole numbers. So I'll start by saying W is this set. So if they are whole numbers, so I'll continue. 3, 4, 5, 6, 7, 8, 9. I'll stop. If the question was if W equals whole numbers between 2 and 10, and they added the word inclusive, it means 2 will be there and 10 will also be there. But if the word inclusive is not there, that means numbers between. You start from 3 to end on 9. So the cardinality, or the number of elements in W, will now be 1, 2, 3, 4, 5, 6, 7, just 7 without any bracket.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.